And then finally, let's talk about some uncertainties. We already know the uncertainty that is caused by standard error, the difference between the real y values and the predicted y values, but actually we have more sources of uncertainty here. Let's discuss them. Okay. Well, actually we have two kinds of uncertainties. Uncertainty in regression coefficient, which is called the sampling error. What is it? You remember we deal with a sample. It's not the same as a population. So if you take another sample from the same population, the regression coefficients will be slightly different, right? So regression coefficients change the position of the line. So instead of this one, we can get this one, or maybe this one, or maybe this one, and so on. So this uncertainty also influences the uncertainty of prediction. Okay. And then finally, the second source is fitting error. It's exactly what we discussed in the previous video. It's a standard error of prediction. And the total uncertainty, it's a sum of these two. So let me show you how to calculate the total uncertainty and how to estimate the uncertainties, for example, for regression coefficients. So remember this, you have a population, this is a true regression coefficients for population, and this is what we got for our sample. And you know that B0 is not the same as beta 0, right? So you always have some uncertainty, which is called a sampling error. Luckily, regression coefficients are distributed like average values. It's normally distribution or t-distribution if you have a small sample size. And then it means that you just need to know the standard deviation of the regression coefficients, standard error of the regression coefficients. And this is how to calculate it. This is how to calculate standard error for B1. This is calculate standard error for B0. Then you can calculate confidence intervals for every coefficient. Okay. The meaning is the same. If confidence interval crosses 0, it means that it seems like this regression coefficient doesn't have any meaning. If confidence interval doesn't cross 0, it means that you have the meaningful regression coefficients in this case. Okay. We will talk a little bit more about that when I show you how to do things in MATLAB. And then you can use this to calculate the uncertainty areas or uncertainty intervals. This is how it looks like. You can see that the red line, the solid line, it's a model. Then you have two dashed lines. These two dashed lines, it's this uncertainty in the position of regression line. So it means that regression line can be everywhere. The real regression line, which we don't know, it can be here, it can be here, can be here. So these two dashed lines gives you this uncertainty in the position of the regression line. Okay. And this is just a formula how to calculate it. You can see it depends on many things, also on degrees of freedom, on the variation of x, on the distance between every point and x. And you can see that indeed this uncertainty depends on the x, right? The more far you go from the average, the bigger uncertainty you get. The bigger uncertainty you get. It's because you have less and less points around this in this area, right? So this is how to calculate uncertainty in the sampling error, the uncertainty in the position of it. And then you know that uncertainty in the predictions, it's just t times se, right? So we know this, it's just a standard error of prediction. And this is how to calculate the total uncertainty. Okay, so that's the formula to use. This part is a fitting error, this part is a sampling error. So altogether, you will get the real error. Okay. And you can see that actually you can simplify this equation. If n is large, this will be very small value. This will be very small value. So when n is large, you can simply use this one, right? The one we used in the previous video. And then many people actually use this one to make the uncertainty instead of this one, especially if the sample size like 30 or larger. You will see that the difference is very small. Okay, so there is nothing wrong in use this one. But you should just keep in mind, so in fact you have another source of uncertainty. This is from the uncertainty of regression coefficient. And then let me just quickly show you how to use this. So let's say this is our model, this is uncertainty formula. You have 32 people in our data set, so degrees of freedom is 31. Okay. Then the t-value for 95% confidence is 2.04. Let's say that's the average of our age, the age of the people. And this is standard deviation for the age of the people. Okay, so this is what we know. And this is standard error of our model. Standard error of our. Now let's say we have a new data point and we have a person who is 36 years old. How big income this person should have in average? Okay. First of all, we need to calculate the income, right? So we just put this 36 to our formula and calculate the income. We should expect 28,000 as an income in average. But how big the variation will be? Well, we can calculate it using these uncertainties. First of all, we calculate this part. Okay, so how far 36 is from the average? Not very far, so that's the value squared distance. Then we calculate this part. So you can see it's n minus 1 times the variance. Variance is just to take a standard deviation and double it and multiply it to itself. So this is this part. So if you take a ratio of this to this, you can see it will be a very small number, right? Then you also have 1 over 32. This one also quite a small number. Then if you combine everything together and calculate the uncertainty, this is the uncertainty. Okay, so this is in 95% cases, the salary will lie within this interval. And if you remember, if you just take 2 standard errors, you will get 8, 4, 54. So you can see that this value is a little bit larger because we, first of all, because we use a slightly larger value for the standard error, it's not 2 and 204, and then also because we have these 2 terms, the uncertainty from the regression coefficients. Okay, so this is how to use the uncertainty, and this is also how to make an inference. And then finally, we need to talk about how to do these things in MATLAB.